Okay. And that is our ecosystem. Ecosystem. Nung Song Sam, ecosystem. Nung Song Sam.
Ecosystem.
Ecosystem.
Everybody together, please. I'm going to see who is talking and who is not. One more time, please. Everybody together. Nung Song Sam.
Ecosystem.
Ecosystem. Well done. Idea. You didn't say anything. The idea. Can I hear ecosystem, please? Idea. You seem to have disappeared, young man. Well, young woman. Not good. Not good at all. Okay. Let's go back. So it's ecosystem. Now remember, we have different ecosystems. Yes, it's true that here we have a plant, an insect, a mouse, and an owl. So for example, if I ask you now to choose an ecosystem that has plants, insect, mouse, and owl, would you say, for example, it is a desert ecosystem? Would you say it is an ocean ecosystem? Or would you say it is a forest ecosystem? Which would you say it is? What kind of ecosystem is all of this?
Forest.
I think you're right. I don't think it's an ocean ecosystem because there's no fish, there's no whales, no penguins, there's no shrimp or lobsters or crabs, and it doesn't look like a desert ecosystem because the plant is a plant like this. It's not a cactus. And there's mouse and owls. I think mouse and owls might live in some parts of the desert, but not usually. So this looks like a forest ecosystem to me. It looks like a forest ecosystem. So let's find out then. And then we talked about, again, the ecosystem of, in this case, let's say a field. In this case, a field ecosystem. When we looked at a field or a forest ecosystem, again, we started with grass and the energy coming from the sun into the grass. We then talked about the grasshopper eating the grass. And remember, we talked about this energy. This is important. We talked about the energy moving from the grass into the insect. Energy moving from the grass into the insect, and then from the insect, in this case, to a frog, and then from the frog to a snake. And then we said from a snake to an eagle. But again, look, it's the energy. Now, one question I want to ask all of you is, which one of these, the grass, the grasshopper, the frog, the snake, or the eagle, which one has the most energy? Which one will have the most energy? Anyone? Which will have the most energy? Which do you think will have lots and lots of energy?
Eagle.
Okay, anybody else got another idea? I think that was Alpha, wasn't it? Alpha saying eagle? Well,
Yes.
yeah, okay. Well, let's have a look. You'd think, yes, it might be the eagle, because what you're thinking, I think, is, well, here's a little bit of grass, and here's a little insect, and here's a little frog, and here's a little snake, and here's a bigger eagle. And we know that the grasshopper is bigger than a piece of grass. We know the frog is bigger than an insect, and we definitely know the snake is going to be bigger than a frog. And for sure, the eagle is bigger than the snake. So you might think, well, this eagle has lots and lots of energy, but maybe not. Because if I had to eat one of these, I think I would choose something else. I don't think I would choose to eat the eagle. And here's why. Look at how the energy from the producer. Now remember, the grass is called a producer. That's because it makes its own food. And because it makes its own food, if I was to take 1 gram of grass, almost, let's say, for example, almost 100% of that 1 gram of grass would be energy. It'd be like taking rice. Rice is a plant. So if I took 1 gram of rice, it would be full of lots of energy. But then the grasshopper would have to eat lots of rice, and the frog would have to eat lots of grasshoppers, and the snake, to keep alive, would then have to eat lots of frogs. So to get 1 gram of energy to the grasshopper would have to eat 2 or 3 leaves of the plant. The frog would have to eat maybe 100 grasshoppers to get 1 gram of energy. The snake would have to eat maybe 200 frogs to get 1 gram of energy. And the hawk or the eagle would have to eat maybe 100 snakes to get 1 gram of energy. So it seems like the grass has more energy than the eagle or the hawk. And when we go up the chain, each one of these will have less and less energy. So if I decide to eat a hawk to get 1 gram of energy, I'd need to eat a lot of them. But if I want lots of energy, I can go straight to my plant. I could eat rice. I could eat wheat. I could eat oats. I could eat any plant and vegetable because they generally have lots of energy. There are some exceptions, celery, for example, but the closer we can get to the producer, the closer we can eat down the food chain, the more energy we will get. And we can see that when we look at the next bit. So when we look at our producers, our herbivores and our carnivores, each one of them will have less and less energy. And we said last week, if you remember correctly, when we had 10,000 units of energy in all that grass, then the eagle would have to eat that many snakes, and then the snakes would have to eat that many frogs, and the frogs would have to eat that many grasshoppers, and the grasshoppers would have to eat only this amount of grass. So we can see that the energy becomes less and less the further we go away from the producer. So yes, the eagle may be the big, strong, tough bird. It may be the big, strong animal, but it has to work very, very hard. It has to eat lots of energy under it to get just 1 unit of energy. But the grasshoppers only have to eat a little bit of grass to get lots of energy. So when you want food and you want energy, try and eat as close to the producer as possible. And is that exactly right? Well, no, because not all energy is passed on. Some energy is lost. And we know it's lost because that's why an eagle has to eat more snakes. Snakes have to eat more frogs, and frogs have to eat more grasshoppers, because not all the energy is passed on. And remember, it's not just forests. We're not talking about just forests. Food chains make food webs, and food webs and food chains can exist anywhere. These ecosystems, these food webs, can exist in the forest, in the Arctic, in what's called the tundra, but also in the oceans and sea. In the oceans and sea, we say something called marine, which means water. So we can see here 2 food chains making a food web, a fish eating a smaller fish, but also a seal that wants to eat a smaller fish. And those would make a food web. And when we connect them all together, you can see an example here of a food web. And then last week, you did this food web, and many of you chose the correct animal to be X. And we asked the question, what is a food web? And many of you wrote down these answers. We said a food web is 2 or more food chains. I asked you to think of an example for organism X. Some of you wrote ant, other of you wrote, I think, mouse or something else. I can't remember now. You chose different animals, or frog. Frog? Would a frog eat a coconut? I don't think so. Squirrel. I think somebody said squirrel. That was a good one. And how many food chains? We said there were 4 food chains. 1, 2, 3, and 4. And we said how many carnivores? And we said the snake and the eagle are carnivores. And we said all the consumers, the animals that eat, or the organisms that eat other organisms. And we said we had the caterpillar, your organism X, the mouse, the snake, and the eagle. Of course, the plant is the producer. And the last question we answered last week was, which is the shortest food chain? And we said papaya, because it's actually a papaya plant, and then rat, and then eagle. That was the shortest food chain. And again, we reminded ourselves that all the energy comes in, goes through the food chain, and then finally goes back into the earth. So this food web takes all the energy from sun to plant to decompose back to the plant again. So before we do our next piece of work, we're going to talk about the key ideas. The key ideas. And I want everybody to understand this carefully. So listen carefully, please. The key ideas were all energy on Earth comes from the sun. That's really, really important for you to remember, because this topic is about energy. It's about energy moving through organisms. It's how you stay alive, because you are getting energy from other organisms, and also not just from organisms, but other animals and plants. Animals and plants. Some of you will eat lots of meat. Some of you will eat lots of plants. And the other key idea was that the animals that produce their own food, that take the energy from the sun, we call producer or producers. And I want everybody to say this word again clearly. So I'm going to say 1, 2, 3, and then I want everyone online to say producer, producer. Nung Song Sam?
Producer.
Not just Alpha. Everybody, please. I'm going to go back and look at your microphones. Everybody, please. I want to hear this word producer. Nung Song Sam.
Producer.
Producer. Well done. Very good. It is producer. Well done. Oh, poor Alpha. You're very tired there. Must have been up late last night playing games. Okay. Idea. Are you back with us yet? Obviously, you've dropped offline. We're going to have to sort this out. This is not good. Okay. The second key word was consumer. Now, remember, consumer is any organism that eats something else. And remember, organisms that eat other things aren't always other animals. Some plants will also eat other organisms. A Venus flytrap, for example, will trap flies and eat it or digest it. They will digest a fly or an insect when the plant catches it. So even some plants can be carnivores, not just big animals that eat meat. Some other plants are carnivores, and some of the plants are also consumers.